All right, so I'm going to go over the questions on homework 13, which is a review for quiz 2 on 5.2 to 5.4. So the first thing is this got printed a little bit weird. So the square root here goes over the 3 and it stops. And then here the square root only goes over the x and stops. Okay, so using the parent graph of y equals the square root of x. Let's remember that the parent graph, we're going to plug in perfect squares, 0, 1, 4, and 9. And we're going to get the square root of those numbers, 0, 1, 2, and 3. Right, the square root of 0 was 0, square root of 1 is 1. So we need to know the parent graph so we can start with that function. And I'm going to put that on my graph in red. 4, 2, 5, 6, 7. My graph actually is too big for the 9, but we'll put it there anyways. I'm not actually going to connect the dots because I'm going to move them to draw my new graph. Now let's describe the transformation. We know that if it says -3 inside the function, that's a horizontal translation, right 3. And -2 on the outside, remember I said this isn't part of the radical, is down, vertical translation, down 2. So each of my points, I'm going to move right 3, oops, that's not right, that's left, right 3 and down 2. So we're going to go right 3 down 2, and I'm going to make my new point. And then the next point at 1, 1 is going to go right 3 down 2 and right 3 down 2. I'm just going to plot those 3 because the other one is going to be too hard to keep on my graph. Now remember that domain and range, domain is the x values that are being used. So this graph got moved over to the right 3. So this graph is starting at +3 and it's going greater than. So my domain is x is greater than or equal to 3. And my range, the graph, the lowest part of the graph here is at -2. And it also goes up, right? The graph is going up. So it's y is greater than or equal to -2. Okay. Now again, same points, 1, 1, or 0, 0, 1, 1, 4, 2. And this time we're going to do a reflection. The negative inside is a reflection on the y-axis. And then a vertical translation up 2. So I'm going to reflect. Well, if I'm here at 0, 0, reflecting it on the y-axis, it stays at 0, 0, and then I go up 2. The point at 1, 1 is going to reflect to -1, +1, and then go up 2. So it's going to be up here at 3. And this point at 4, 2, -4, it's going to reflect over to -4, 1, 2, 3, 4, and then up 2. And now it's at 2, and I'm going to go up 2 for the transformation because this point's already at 2. And so I'm going to be at here, and then we'll connect that. Now this domain starts at 0 because the x value at the y-axis is 0, and it's going less than. So my domain is x is less than or equal to 0. But my range is still going up. My graph is still going up from +2. So my range is y is greater than or equal to 2. And then number 3, we have 0, 0, 1, 1, 4, 2. My graph is a reflection in the x-axis, and then a vertical translation down 3. So all of my points, again, if it's on the axis and I'm reflecting over the axis, it's not going to move, but then I'm going to go down 3. Now this point at 1, 1, reflecting on the x-axis, is going to go down to -1 and then go down 3. And then the point at 4, 2 is going to reflect to -2, and then it's going to go down 3. So it's going to be right there. And then I'm connecting. Now my domain, starting here at 0, and it's going greater than. So the x values are going greater than or equal to 0. But my y values are starting at -3, and they're going down So it's y is less than or equal to negative 3. Okay. Okay, so we talked about using that as a vertical translation, so we can make a table if we'd like, or we can do transformations on this one. That's going to be up to you, but you need to write out your transformations if you're going to do it that way. So first of all, I'm going to start with this table. I know that if I plug in 1, I get the square root of 0, right? And we looked at yesterday, or today in class, that it's done in stages. The x minus 1 you calculate first. Then you do the square root of that. Then you multiply it by negative 2. And then lastly, you're going to add 3. And we want to pick numbers that are going to make this 0, 1, 4, and 9. So as I look for those numbers, what number minus 1 is equal to 1? Well, that's 2. 2 minus 1 is 1. And what number minus 1 gives me 4? Well, 5 minus 1 gives me 4. And 10 minus 1 gives me 9. Then when I take the square root of that number, I get 0. When I multiply it by negative 2, I get 0. Hello. And then when I add 3, I get 3. So that gives me my first point, 1, 3. Then if I plug in 2, 2 minus 1 is 1. The square root of 1 is 1. 1 times negative 2 is negative 2. And negative 2 plus 3 is 1. So my point is 2, 1. And then when I plug in 5, 5 minus 1 is 4. The square root of 4 is 2. 2 times the negative 2 is negative 4. And negative 4 plus 3 is negative 1. So my point is 5, negative 1. And this one's not going to fit on my graph, but we'll do it anyways. The square root of 9 is 3. 3 times negative 2 is negative 6. And negative 6 plus 3 is negative 3. And so we'd have the point 10, negative 3. We're taking these x values and these y values. Okay, so if I plot those, I get 1, 3. I get 2, 1. 5, negative 1. And 10, negative 3. And that graph goes like this. My domain, x is greater than or equal to 1, because it is going to the right, towards the positives, but my range is going down, so it's less than 3. Y is less than or equal to 3. Okay. So that's doing it with the table. The other way to do it is to use transformations. Okay, so I'm going to erase this and show you how I would use the transformations. Starting with 0, 0, 1, 1, 4, 2, 9, 3 is out here. So my transformation is to the right 1. Okay, so right 1. And then it's a vertical stretch of 2, a reflection in the x, and then up 3. And I have to do it in that order. So 0, 0 is going to move over to the right 1. When I stretch by 2, that means I multiply the y value by 2. Well, the y value is 0, and 0 times 2 is still 0. When I reflect 0 in the x-axis, it stays at 0, and then I move this one up 3. Now this is the one that's going to change more. When I have 1, 1, I move right 1, so I'm here. Then I multiply it by 2. 1 times 2 is 2. It moves up to here. Now I'm going to reflect it down to negative 2. Okay, so now I'm here at negative 2, and then I move it up 3. You can see I'm back at that point 2, 1 that I calculated earlier. And then I'm just going to erase those intermediate points that I used, so I don't get confused on what I'm connecting. And then, so this one's at 4, 2, so I'm going to move it right 1. I'm going to multiply 2, the y value by 2, so it's going to be up at 4. It's going to reflect and go to negative 4, and then it's going to go up 3. And there is those 3 points. You can see they align with the points we got from the table. So that's 2 ways to do that problem. Now, if you're doing the problem with the horizontal translation, I highly recommend the table. So first thing I'm going to do to see what my table is going to start at is I want to know what's going to make the square root 0. As soon as I figure that out, that's where my table starts, because that's where my graph starts, with 0, because that's the lowest the square root can be. So when I subtract 2, 1/2 x equals -2. To get rid of the 1/2, we multiply by 2, and I see that x is equal to -4. And that's actually my domain, x greater than or equal to -4, because there's no reflections. Okay, so my table is going to start at -4. Then I'm going to do 1/2 x plus 2, and my goal is to be having 0, 1, 4, and 9 there, and then I'm going to do the square root of that. And that's going to give me 0, 1, 2, and 3. So I really have to just figure out what x values are going to give me these results. Now, one way to do it is the next number is -3. Is -3, 1/2 times -3 plus 2 is going to give me a fraction, and I don't like that. So let's try -2. 1/2 times -2 plus 2 is -1 plus 2, which is 1. That's a perfect square. That's the number I wanted there. That's what I want here, and so -2 goes here. So 1, I could go through all of the numbers until I get what I want under the radical. Try -3, try -4, try -5, try -6, and pick out the ones that give you what you want. Or you can solve. I want 1/2 x plus 2 to equal 4 now. So I'm going to subtract 2. 1/2 x is equal to 2 times by 2, and x is equal to 4. So 4 is going to give me 4. So when I plug 4 in, half of 4 is 2. 2 plus 2 is 4. And then I can figure out what's going to give me 9, but I don't really need it because it's going to go off my graph. Plus 2 equals 9. 1/2 x equals 7 times by 2, and we get 14. Right? So that is the other way to do it. Just solve it algebraically instead of guessing. Or, in your head, you can kind of go through and see which numbers are going to get there, but solving will get you there every time. Now I'm just plotting my points, -4, 0, right? I'm plotting these with these. The intermediate was just what's under the radical. And then -2, 1, and 4, 2. And then 14's way over there, so I'll just connect those. And this is a horizontal stretch, so you can see how it is stretched out horizontally away from the y-axis. And my range, y greater than equal to 0. Okay, on to the back side. I'm going to multiply these together, simplify, divide, knowing that I can multiply numbers that are outside the radical. I can multiply numbers together that are inside a radical. I can't multiply the number outside with the number inside. So I'm going to multiply by 2 and 3. I get -6, and the 4th root. Instead of writing 8 times 12, instead of doing 8 times 12, I'm going to write this as 4 times 2 and 4 times 3. Okay, there's your 8, and there's your 12. Now I can break it down a little bit more, and I'm not doing extra work. So 4th root of 2 times 2, that's the 4, and there's the 2. And then 2 times 2 is the other 4, and the 3. Now this is 4th root, so I need 4 of a kind. So I have 4 of a kind in 2's. So the 4th root of 4 2's is going to be 2. Okay, so that becomes that 2. And then the 4th root of what's left, 2 times 3. And multiply together what's outside, -12. Multiply together what's inside, 4th root of 6. Okay. Let me just move it that way just a tad. We'll just circle those again. Okay. Now, the next one, Again, I am not going to multiply 24 times 16. I don't know what that is on top of my head. I'm just going to write that as 8 times 3, and 16 is 8 times 2. And I know, okay, here's another way of looking at it. I know what the cube root of 8 is. The cube root of 8 is 2. There's 3 2's in there. So I end up with outside 2 times 2. The first one for that 8, the second one for that 8. And then I don't have any more repeats, so 3 times 2 is 6, stays inside, -4 cube root 6. Okay. So again, oh, wait, I forgot about this 2 out here. That 2 escaped me. So we're going to multiply it by this 2, and then this is going to become an 8, because 2 times 2 times 2. Okay, so this, I forgot to put that 2 in front. Okay, so let's be more careful here. -2 times -5 is 10. 32 is 16 times 2. 18 is 9 times 2. Again, I know the square root of 16. That's 4 times 4. I know 9 is 3 times 3. So I end up with 10 times 4 times 3, and I have a pair of 2's times 2. So nothing is left under the radical. We have 40 times 6. 40 times 6, which is 240. Okay, so number 9, we're multiplying a binomial by a radical. We're going to distribute. 2 times square root 5 is just 2 square root 5. And then I can, again, 5, and 10 is 5 times 2. So I have a pair. Okay, so again, I'm not multiplying it to make it 50. That just makes my life harder. I'm going to break them down as I put them together. So 2 square root 5 minus 5 square root 2. And I can't combine them because they have different numbers under the radical. Number 10 is very similar. 4 times the cube root of 6. So 4 cube root 6 minus the cube root of 3 times 2. And 12 is 4 times 3. And that's 2 times 2. So I have 3 2's. Cube root needs triples. So that's 2 cube root 3 times 3 is 9. Because that 4 was those 2's. Okay, now we have the dividing. We can't have a radical in the denominator. We can't have a fraction in a radical. So we need to rationalize the denominator by making the radical go away. In order to make the radical go away, if it's 4th power, I need 4 of something, something to the 4th power. If it's 5th power, I need something to the 5th power. So as I look at my denominator, I see I have 1, 3, and I have 2 x's. I have 1. I need 4 to make it a perfect 4th power. So whatever I do to the bottom, I have to do the top. 3, I have 1, 3. I need 3 more. Multiply by 3 3's. I have 2 x's here, 2 x's. I need 2 more. Whatever I do to the bottom, I'm going to do to the top. And that's 3 times 3 times 3 is 27. I'm just going to multiply the top together. 27 times 2, that's the 4th root of 54 x squared y. I like my variables alphabetical. If you put yx squared, that's okay. Now what happens in the bottom? I have the 4th root of 4 3's. Okay, I end up with the 4th root of 3 times 3 times 3 times 3. That just equals 3. And I get the 4th root of x to the 4th, which just equals x. And that's my final answer. The whole goal of that was to make the bottom, so it's just 3x. Okay, if we look at number 12, I have the 5th root of 2. So I'm going to multiply by the 5th root of, I have 1 2, I need 5. So I need to multiply by 4 more 2's. And whatever I do on the bottom, I got to do on the top. 4 more 2's. 2 times 2 is 4, times 2 is 8, times 2 is 16. So 4 5th root of 16. On the bottom here, I get the fifth root of 2 times 2 times 2 times 2 times 2, 5 2's, so that equals 2. Now, because the 4 and the 2 are both outside the radical, I can divide, and I get 2 fifth root of 16. Okay, number 13. 9 is not a prime number, so I want to break that down to help me out here. 9 is 3 times 3. That's going to keep my numbers smaller. It's a cube root, so I need 3 of everything. I need 3 3's and 3 A's. I have 2 3's. I need 1 more. I have 1 A. I need 2 more. So I can multiply by 3A squared. Right? This number dictates how many I need. So we'll do it on the top. So I have the cube root of 6A squared in the numerator. And in the bottom, I got the cube root of 3 cubed, which is 3, and the cube root of A cubed, which is A. Number 14. Biggest mistake on this problem is not recognizing you have a perfect cube. Let's break it down. 2 times 2 times 2x squared. Well, I already have 3 of them, so this is technically 2 cube root of x squared. And the only thing I need to multiply by is 1 more x. So I'm going to multiply by the cube root of x. Because I have 2 x's, I need 1 more to make it 3. Multiply by the cube root of x. I got the cube root of 2x over 2x. And I can't simplify that because I have a 2x inside the radical and 2x outside the radical. All right, number 15. Lots of radicals here. I can add and subtract radicals when they have the same index and the same radicand. What I need to do is simplify my radicals to see which ones actually do have the same index and radicand. So 16, I know, is 8 times 2. 8 is 2 times 2 times 2 times 2. I can take 3 of those out. So that's negative 2 times 2, and what's left is cube root 2. So I have negative 4 cube root 2. 2 can't be simplified more, so I'm just going to bring that down. 5 cube root 2. 27 is 9 times 3. 9 is 3 times 3. I have a pair, so that becomes minus 3 radical 3. 54 is 27 times 2. 27 is 3 times 3 times 3 times 2. I have a triple. So I have negative 5. What comes out is the 3. And what stays inside is cube root 2. So I end up with negative 15 cube root 2 and plus 4 square root 3. Now let's find my like terms. I have negative 4 cube root 2's plus 5 cube root 2's minus 15 cube root 2's. And I'm just going to add up the numbers in front. Negative 4 plus 5 minus 15. Negative 4 plus 5 is 1. 1 minus 15 is negative 14. And what was I counting up? Cube roots of 2. And then with my square root 3, I have negative 3 square root 3 plus 4 square root 3. That's going to give me plus 1 square root 3. You can write the 1 if you want, but I don't usually. Okay, number 15. Again, my like terms, we're going to see we have 3 square root 2 minus 2 square root 2 plus 7 square root 2. Don't forget that this one has a 1 in front. Okay, so that's 3 minus 1 is 2, plus 7 is 9 square root 2's. And then I have 4 fifth roots of 6 minus 8 fifth roots of 6, which gives me negative 4 fifth roots of 6. Okay, biggest mistake is not adding that one or subtracting that one in because there is 1 there. Okay. All right, now we're going to simplify these radicals using absolute values when appropriate. The rule is when it's an even index with an even power underneath and the answer comes out as an odd power, it needs the absolute value. Okay. And so I have the square root of negative 3 to the 12th. Remember that that is a 2. I can divide my exponent by my index, and 12 divided by 2 is 6. So negative 3 to the 6th power. Now this was an even index. This is an even power underneath, but my answer came out even, so I don't need the absolute value. Negative 3 to the 6th power is 729. It's going to be positive because a negative to an even power is positive. And 4 square root, fourth root of 81, a to the 12th, b to the 24th. So it's even, starting out even, so I'm going to have to think about if I need the absolute value. The fourth root of 81 is 3. 12 divided by 4 is 3, so that's a cubed. And 24 divided by 4 is 6, b to the 6th. Now this is even. The 12 was even. It came out odd. The a is going to need the absolute value. But the b came out even. The b does not need the absolute value. So I'm going to put my absolute value around the a cubed. Okay. Number 19 is odd. Don't need to worry about the absolute values. Don't need to worry about that negative. It's allowed to be negative if it's an odd root. So the cube root of negative 8 is negative 2. Now when I divide 5 by 3, I get 1 remainder 2, right? 3 goes into 5 one time. 5 minus 3 is 2. So I'm going to have a to the first power outside, and I'm going to have x squared stay inside because it didn't have enough. There wasn't 3 of them to bring it out. Now we're going to divide the 13 by 3. When I divide 13 by 3, I get 4 remainder 1. All right, 4 times 3 is 12. 1 more gives you 13. So then I get y. Oh, I don't know why there's an a here. That's supposed to be x. Okay, so that is y to the 4th outside, y to the 1 remains inside. So the remainder remains inside. Now again, this was odd, so I don't need to worry about absolute value. Okay, so red flag on this problem, negative under an even, this one is no real solution. Because I can't take the fourth root of a negative. Number 21, 6th root's even. So even, odd. I'm going to have to think about that. The 6th root of 64 is 2. 7 divided by 6. 7 divided by 6 is 1, remainder 1. So 1x stays, x to the first goes outside, and 1x is going to stay inside. And then 6 goes into 20 3 times, remainder 2. So I have y squared inside, the remainder inside, and y cubed outside. So now let's assess even, odd. Don't have to worry about it, because if x was negative, the whole thing would be undefined. Even, and the 3 came out odd, so I need the absolute value on the y cubed. Because there is no way y to the 20th is going to be negative, and so if y was negative, this would make the whole thing negative, and they wouldn't be equal to each other. And lastly, on this set, the 5th root of 32, a to the 15th, b to the 7th. The 5th root of 32, 5th root, don't have to worry about even, odd. So that's 2. A, 15 divided by 5 is 3. 7 divided by 5 is 1, so b to the 1. But remainder 2, so I have the 5th root of b squared inside. Again, it started odd, so I don't need to worry about absolute value. Now, if you are in Mrs. Whipp's class, your last 3 problems are different than these on my worksheet. So you could stop the video now. For Olson and Lawler, we did inverses. And so when we found the inverse function, we saw with our amplify activities that we could change the f of x to y. And if we swapped our x and y, because the inverse is a reflection in the line of y equals x, so I can flip them around, and I get y by itself, solving for y will give me my inverse function. And I'm going to undo this equation just like if I was solving it. I'm solving it for y, so I'm going to undo the minus 8, and I'm going to add 8. And I get x plus 8 equals 2/5 y. And to get rid of a fraction, we multiply by the reciprocal, so I'm going to multiply by 5 over 2. And I get 5 over 2 times x plus 8 equals y. So f inverse of x is equal to 5 over 2 times x plus 8 in parentheses. If you want to distribute 5 over 2x, 5 times 8 is 40, divided by 2 is 20. So 5 halves x plus 20. Okay, number 24, I'm going to just start with x equals 2 cube root y minus 7. Okay, you can write y equals if you want. And now I'm going to solve. So I'm going to get x or y by itself by adding 7. X plus 7 equals 2 cube root y. I need to get rid of the 2 before I do the cube root. So x plus 7 over 2 equals a cube root of y. And I'm going to cube both sides of my equation. And I have x plus 7 over 2 cubed equals y. And so f inverse is x plus 7 over 2 to the third power. F inverse of x. On number 25, x equals y minus 5 cubed plus 1. Subtract your 1. X minus 1 equals y minus 5 cubed. Undo the cube by taking the cube root. Cube root of x minus 1 equals y minus 5. And we're going to add 5, but we're going to add it outside the radical. X minus 1 plus 5 equals y. So the inverse is a cube root of x minus 1 plus 5. And lastly, number 26 says 2x squared plus 3 when x is greater than or equal to 0. We talked about and saw in Desmos, if we don't restrict the domain on the even powers, it doesn't have an inverse function. So this is going to be a parabola, but we're saying, let's just look at this half of it, the positive half, and then it has an inverse function. So I really don't need to do much with this. I just need to know that that means I can find the inverse. So again, x is equal to 2y squared plus 3. And we'll subtract 3. X minus 3 equals 2y squared. And then divide by the 2 before you undo the square. X minus 3 over 2 equals y squared. Now we can square root both sides. And we don't plus or minus. Because this is greater than 0, it's positive. If it said x is less than or equal to 0, we would make it the negative square root. That's the only thing that does. And so f inverse of x, because those cancel, is equal to the square root of x minus 3 divided by 2. There you have it. A detailed explanation of how to do every problem on homework 13.